Well, happy snow day to you. I am sitting on my couch with my fuzzy slippers on and the fire in front of me and my dog surrounding me, creating your lesson for today. Hopefully, when you get to watch it, you get to be in similar comfort instead of getting into the classroom at 8 a.m. There will be two videos for you to watch in lieu of class today. They will count towards class participation. So there'll be this one, and then there will be, that's where I'm a reminder to go to class. I think I'll stop that. So we will have this one, which is going to deal with balancing reactions. And with this one, we're going to need to do a skill building to help make sure that we understand how to balance reactions. This is going to be due Wednesday night, and it will not be accepted late. That's because I'm going to post the key. As soon as it becomes due, the key will get posted, and that way you can see if you are able to balance reactions correctly. Then, of course, we have an exam on Thursday. It will be, of course, in class. You will need to bring your laptop or your iPad with the lockdown browser installed, just as you did for our first quiz. Make sure you realize that our learning outcomes is your study guide. Look through it. It is clearly marked with where you stop for this exam. Now, I've got extended office hours for Wednesday, so be sure to check out the announcement that I posted for times and locations of those office hours. So let's get into balancing chemical equations. First of all, let's define what an equation, a chemical equation, is. This is a shorthand notation used to describe a reaction. So, in this example you see here, hydrogen, which is a gas, is going to react with oxygen and is going to produce water. So, on this side of the reaction, these are called reactants. And they are what you put in to react. On this side, these are called your products. Okay, and they are what is going to be formed by the reaction. So when hydrogen and oxygen react, they produce water. Now, this is telling us more than just what are the reactants and what are the products. It also demonstrates the law of conservation of mass, meaning matter in a reaction cannot be created or destroyed. So a good chemical equation is going to represent that happening. So let's see if I can erase everything on this slide quickly here. No. There probably is a way, but I'm going to just erase, okay? Because I want to talk more about this reaction and what we're seeing that shows us that the law of conservation of mass is being obeyed. When we look at this, we need to understand what it is representing. The H2, that does not look like a 2. Let's try that again. The H2 represents a molecule with 2 hydrogen atoms in it. Okay, so that's what the H2 is representing. Now, in front of that H2 is a number 2. That number 2 that you see there is called a coefficient. A coefficient is the numbers in front of our formulas, and it tells you how many of the hydrogen molecules you have. So that 2 coefficient is telling us that there are 2 H2 molecules. Okay, so we have a 2, and then we have an H2, and that says that there's 2 hydrogen molecules. What we need to be able to do then is say how many hydrogen atoms are in that representation. So think about it. If there are 2 H2s, how many hydrogen atoms are there? Well, hopefully you said there are 4. 4 represented on the left-hand side of this reaction. Now, if we are going to demonstrate that matter in a reaction cannot be created or destroyed, which is what we're seeing stated right here, we must determine that on the product side there are also 4 hydrogen atoms. So let's erase this and get some space here for me to examine the product side and think about the hydrogen atoms. As we look on this side and we look at just the H2O, we have a question here. How many hydrogen atoms are in one molecule of H2O? Well, there are 2. So now we get the coefficient involved. Again, in this case, we have a coefficient of 2. This is telling you that there are 2 water molecules. If there are 2 water molecules, then how many hydrogen atoms total do we have right here? So let's put an arrow and ask the question, how many total hydrogen atoms are on the product side? And again, the answer is 4. 2 water molecules, each water molecule having 2. So we're multiplying. The 2 coefficient times the 2 subscript tells you that there are 4 hydrogen atoms. The 2 coefficient with the 2 subscript tells you there's 4 hydrogen atoms. And that is the same hydrogen atoms on the left as there are on the right. So the hydrogen was not created nor destroyed. Now let us examine that for the oxygen next. So we're going to keep looking at this same reaction. Okay? And we look at the left-hand side for oxygen. Well, we don't see a coefficient in front of it. And whenever there's no coefficient written, that means there is one of them. Okay? We just don't write that one. So there's 1 oxygen molecule. Each oxygen molecule has 2 oxygen atoms in it. 2 times 1 is a total of 2 oxygens on the reactant side. As we look at the water molecule, we have no subscript written. We know that that means that there's 1 of them. There's a 2 in front. 2 times 1 is 2 oxygen molecules on the product side. So oxygen is obeyed. Now, what you're going to need to be able to do is, if given a reaction that's not balanced, is you balance it so that it has the same number of each type of element on the reactant and product side. So let's see how this is. Okay, well, you're going to write the correct formulas for the reactants and the products. In this class, they will always be given. Okay, I won't make you come up with those good formulas. Then you are going to use coefficients in front of the formulas to balance the equation. Never, 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 never change the subscripts. You're only allowed to use coefficients. And it says here to begin by looking for elements that appear only once on each side of the equation and balance them first. Okay? So you're looking for things that only appear on each side once. If something appears on one of the sides in more than one place, save it. Okay, save it for later. Let me see if I can think of an example. If you were going to balance CH4 plus O2 goes to carbon dioxide and water, oxygen appears in more than one substance on this product side, so I would save it for last. So that's what I'm meaning by this statement right here. You want to begin with things that only appear once instead of twice like we're seeing in this case. All right, so let me walk you through some examples. I don't have a situation here where anything is appearing on a side more than one place. So the sodium is in one place on the left and one place on the right. The chlorine is in one place on the left and one place on the right. So doesn't matter what we start with. So I tend to, when it doesn't matter, start and just work left to right. So when I look at my sodium, I see that I only have one sodium. There's no subscript, there's no coefficient, so both of those mean they're one. And on the right, the same thing is true, okay? There is an assumed 1 after the sodium. There's assumed 1 in front, so there's 1 sodium. So at this point, the sodium is balanced. That doesn't mean it's going to stay balanced because now we have to look at the chlorine. When I look at the chlorine, there is a 2 subscript there. That means I have 2 atoms of chlorine on this reactant side. So I need 2 atoms of chlorine on this side. And right now, I only have 1. Now the rule is you can't change the subscript. It would be really nice if we could go in there and do that. Now I have 2 atoms. That is not allowed. Why is that not allowed? Because sodium chloride must be NaCl based upon the fact that sodium has a +1 charge, chlorine has a -1 charge, and we learned that by looking at the periodic table. So the formula has to be NaCl. I'm not allowed to change the subscripts. So I'm only allowed to put coefficients in front. So I choose a number that will give me 2 chlorines on the product side. And I'm only allowed to use coefficients, so I put a 2 in front. Does that give me 2 atoms of chlorine? Yes, 2 times the 1 that is assumed right here is 2 chlorines. But what did that mess up? Well, that messed up my sodiums, which I thought were already balanced. So now, how many sodium atoms have I got on this side? I have 2 NAs on the product side. So I must need 2 sodiums on the reactant side. So how do I do that? I'm only allowed to use coefficients, so I put a 2 right there. The last thing you should definitely do is check your work. It is easy to figure out whether or not it's balanced. So we go through and we look at each element. I have 2 sodiums on the left. I have 2 sodiums on the right. I have 2 chlorines on the left. And because that 2 coefficient is in front of the whole thing, I have 2 chlorines on the right. So that means it's balanced. Okay, let's try this next one. There's sulfur only appears in one place on both sides. Fluorine only appears in one place on both sides. So I know that I have, it doesn't matter what order I do things in, so I'm just going to work left to right. On the left, on the reactant side, I have 8 sulfurs. I need 8 sulfurs, so I have to put, only choice is to put an 8 in front of there, and now I have 8 sulfurs. So now we're ready to think about the fluorines. On the left, I have 2 fluorines. On the right, how many fluorines do I have? Well, 8 times 4 is 32 fluorines. So I have to come over to the left side and come up with a coefficient in front of the F2 to give me 32 fluorines. Well, if every fluorine has 2, already had that subscript, what times 2 gives me 32? Well, that's a pretty big number. 16 times 2 is 32. So that would be the fluorine's coefficient. Then we should check, right? 8 sulfurs on the left, 8 sulfurs on the right. 16 times 2, 32 fluorines on the left, 8 times 4, 32 fluorines on the right. So there is our balanced equation. All right, so if this is a struggle for you, make sure you practice with it, with your skill building, and feel free to come by in office hours to get some help with it. I'm happy to help you in any way.